Hello everyone, welcome to our project showcase focusing on the geopolymer cement design for nuclear waste encapsulation. To begin the introduction, I'd like to focus our attention to the CO2 footprint produced by ordinary Portland cement, or OPC for short. OPC is the principal material for modern-day nuclear waste encapsulation, as well as other infrastructural uses. However, it is also the principal contributor to CO2 pollution of the atmosphere at approximately 8% of the global CO2 emissions. The growth of OPC production has grown considerably since the early 20th century, as seen on the image above, and this alone is a strong driving force for the design of an alternative encapsulation material, such as different geopolymer mixes, or GP mixes for short. The main stakeholders of the project will be industries that produces and uses OPC, who are looking to reduce their carbon footprint, as well as nuclear waste encapsulation sites and the general public, who are looking for better cesium encapsulation material. The project objective here is to optimize and evaluate a specific GP mixture with varying percentages of fly ash, sodium hydroxide, and water glass. The weight percentage of each constituent material will be varied within a sponsor's suggested range to optimize the mixture properties and allow for characterization. For this project, we will be designing a statistical experiment to determine composition, setting temperature, and cesium content to meet the objectives of achieving base structural and chemical properties of OPC, reducing CO2 footprint by at least 80%, and exceeding the cesium leaching index of OPC by an order of magnitude.
The design options were generated using a statistical analysis software for experimental design known as Design Expert, or DX for short. This allows us to model the relationship of variables to responses. We initially tested and optimized geopolymer composition to maximize compressive and tensile strength. From here, we can obtain a resultant mixture that meets our criteria and carry it over to our next step. Now, with our final goal of maximizing leaching index in mind, we furthered our statistical analysis using the previous composition. We tested its impact with new parameters. These parameters were temperature and cesium content, and we optimized them for maximal leaching index, compressive strength, and open porosity.
The final design was successful in accomplishing the project goals, where the designed geopolymer exceeds the chemical and structural properties of ordinary Portland cement, as shown by the comparison of the upper right highlighted numbers and to the ones on the bottom. A higher leaching index and compressive strength allows for greater nuclear waste encapsulation, which is to the benefit of public health and safety. The impact of our final design is a 6.24% reduction in costs, along with a total reduction of 61.7% in CO2 emissions. Although the cost will increase should we upgrade to a larger industrial scale, this project and our design clearly demonstrates the environmental benefits of replacing OPC that's commonly used in industry with geopolymers. This concludes our project. Thank you for your attention.